All right, everyone. We are going to take up our practice quiz. So again, our goal was to do, right now, just because we sort of just learned it, so you could do all 3 questions that I gave you in about 15 minutes, 5 minutes each. If not, the amount of time I gave you was 20. Let's do it. Okay. It says complete the square and write the function in vertex form. So part of the step was, I'm going to go a little bit faster because 1, it's recorded, and 2, this is basically what you would have done in your homework. Okay. Separating the first 2 terms with the third. Next, I am trying to create a perfect square trinomial. So that's x squared plus 10x plus 25 minus 25. Right, so divide by 2 and square it, which gives you 25. And you can't just do that out of nowhere, so I'm going to take that away as well. Moving on, I need to keep the first 3 because I like it. I can factor that. Remove the 4th, which leaves us to negative 25, negative 13. I'm going to simplify that all right away because I'm going to have to do it anyway, so might as well just get that done. Factor this, it would be 10 divided by 2, that number. Remember that from yesterday, right? Whatever that number is, you already know what this number is, just by dividing it by 2. And so this would be 2 of these binomials, x plus 5 times x plus 5. Knowing that's always going to be the case, again, from our practice, you see that it's always going to be double. And repeat my shortcut, bam. Even with an explanation, that only took 2 minutes. Now, it was a little fast, of course, and I know I've done this many, many times, so you can say that's a little unfair, but try to get to that point. If you felt that it helped to talk out loud, like I did, go for it. Number 2 was a little bit harder, but it's virtually the same thing, except 1 more step. I am separating the first 2 terms from the third. But there's one more thing that I'm doing here that's different from the left question, and that is I want to get the x squared all alone, just like this. I want a 1 in front of it. So I'm going to common factor the 3 out. Oops, leaving me with 2x, negative 2x. Now, don't mind the 3, don't mind the 4. I'm going to work with this binomial and turn it into that nice perfect square trinomial. To do that, of course, you take that middle term of negative 2, divide by 2 and square. It should be plus 1 and a minus 1. Again, I like my trinomial. I want to keep this, which means I am removing this. But when I removed it here, I could just remove the negative 25 over. Here, it's going to be affected by the multiplication of 3. So this actually becomes, here's my perfect square trinomial, and this becomes negative 3 plus the 4. My final answer is negative 1 plus 1. You've just done these questions, so it should be relatively fresh in your mind where you might have made a careless error, or you had a misunderstanding, or you plumb forgot it and couldn't make sense of the instructions from your cheat sheet, whatnot. Now is another time to reflect whether your study sheet needs some work. If you felt your study sheet was very, very useful, well then, you don't have to edit much for Monday. But if you felt that even if you were looking at your study sheet, it was not helping at all, well, tweak it. Absolutely tweak it. Any questions before we go on to our word question? Okay, let's do it then. Our word question, I'll just clear this, involves, I'll just read it for you. A ball is thrown vertically upward off of a roof of a 34-meter tall building. So it's always nice to have a little visual. So I'm going to be like, whoop, I'm throwing it. Okay, it's about to be thrown. and it's going to be thrown upwards, and I'm assuming it's going to fall because of gravity, so we're not in space or anything. Okay? It's going to be upward, and this, I'm assuming the height of the ball is going to be 34. Whatever the height that the ball is starting is going to be about 34. The height of the ball is with respect to time, and it can be modeled by the equation okay. I don't think I need this video, by the way. Time, t is time in seconds after the ball is thrown, and height is in meters. Find, the question says, the max height, okay, as well as when it's max height. What are they looking for? Well, with the keyword max and min, let's think about the vertex. I think they're going to look for the vertex. So in this case, it's not x and y, it's going to be time and height. What's the max height? Oh, that must be looking for that number. When does it happen? They must be looking for that number. They just want both numbers, but spoken differently. So if they want in vertex, I think it's in our best interest to compute the square. So I'm going to take this. I am going to go right into it and separate the first two terms from the last. I want the variable squared term all alone, so no coefficient. I am going to factor out a -5 leaving this. So check your line right there. Did you factor a -5 correctly, leaving us a square and a -2? On. Take that middle number, divide by 2n squared. It gives me a +1. And of course, I subtract that same number. I like my first three terms because it gives me a perfect squared trinomial, which means I have to remove my -1, leaving me with +34 and +5. There it is. We just did a practice quiz, so you'll see that our quiz on Monday will be very similar, very similar to what I'm giving you right now, a single page, single side. Okay. We've got this to be, if I factor it, it's going to be t-1 multiplied by t-1. So I'm going to write it as a square. My vertex is 139. What does that mean? It means at 1 second after the throw, the ball reaches max height, 39 meters. A couple of things you can do to check. Does it make sense realistically? We started at a height of 34. Does it make sense that it goes to a 39 before falling? Yeah. An extra 5 meters before going down? It would be weird if the question said the ball is thrown upwards, but then the max height was like at 23. That doesn't make any sense, right? Clearly, from 34 meters tall a building, if you throw it upwards, the max height has to be bigger than 34. If your max height is lower than that, you might want to scratch your head and say, that doesn't make any sense. Did I do something wrong? With the time, does it make sense that the ball reaches max height after 1 second? I'm going to say yes. And if you remember your catapult, it really didn't take long for it to land, right? It took like in 1 second, it went from start to finish. Gravity isn't actually as weak as you might think. Right? So for a ball to travel 1 second before falling down, right? Sort of makes sense. Now, of course, if you play basketball, play baseball, or through a heavy rock, it'll fly a lot longer than that, I'm sure. But then just all you're checking is whether it seems realistic or not. Any questions? Okay. As I said from yesterday, from the textbook pages, there are a handful of questions you can try in preparation. There's so many normal complete the square questions, and there's a little less word questions like you see in this quiz right now. So find them from the textbook. If you are having trouble with that, ask me, email me, do what you need to. I'm going to transition into our final lesson. So if you want to, I don't know, give yourself a mark or something and then file it, that would be great. Come on up and grab our sheet on the left. Chapter 4.3. Once you're done with this, once you have this quiz filed out, come grab our lesson for today. Hey everyone, this is going to be a completely different shift from what we've been doing until now. I'm going to ask you to remember this sheet that I gave you earlier last week? No, earlier this week. Take a look. If you remember, I talked about how in chapter 4, we're going to be learning ways to go get around some of these other techniques, right? Chapter 2 and 3 forced you to factor, get the x-intercepts, get the axis of symmetry, and then get the vertex. In other words, it's forcing you to factor so you can find the x-intercepts, which will help you find the axis of symmetry, which will help you find the vertex. So far, so good, right? You don't have to remember it just yet. I mean, I like you to understand what I mean when I use these words. Up 4.2, what the quiz that we just did, got you to do this. You go from a random, a regular standard form of an equation, and then you go straight into vertex form. And this part would be called completing the square. Right? That was this big arrow. Right. Yeah. Today is the second, I guess, technique of chapter 4. If you can complete this chapter 4, then the rest of chapter 4 is going to be relatively straightforward. It's not really new techniques, it's just ideas that they want you to know. So let's do this. The question is this: to go from polynomial form or standard form and to get the x-intercept because it's helpful, you need to factor. But my question to you is, what if it's not factorable? If you cannot factor, you're going to say it's impossible? No. Today's lesson is called the Quadratic Formula. So at some point in your weekend, if you want to update this sheet in 4.1 and add these things in there, it might help you visualize a strategy when you're getting a word problem in the future. So you're going to look at, I'm going to show you an example of when something is factorable and bam, you can get the x-intercepts. Then what do you do when they're not factorable and bam, you can still get the x-intercepts? So consider this. I'm going to share my screen now. All right. Here we go. All right, I have with me one trinomial, which I'm going to show you can solve this by factoring and find the x-intercept by factoring, or you can do it by quadratic formula and you get the same answer. Let me recap what the quadratic formula is. When you are given an equation in standard form, you can automatically identify what is A, B, and C. What is the value? What is the coefficient of x squared right now? 1. What is the coefficient of b? Sorry. What's the coefficient of x? -8. And for c, 12. These three values are where you're going to plug in, or are what you're going to plug into the equation. That's it. The quadratic formula is a really funky looking thing where the x value we are looking for, or the root, or in this case, it will be the x-intercept, is equal to the negative of b plus minus the square root of b squared minus 4ac over 2a. And that will give you answers that make the statement true. Consider this, okay? Take a look. So in other words, this quadratic formula will allow you to find the x-intercepts no matter what. Anyone here who doesn't feel comfortable with factoring, you know that you could use this and still find the x-intercepts. It's another tool for you. Here we go. We are going to revisit factoring. Here's my equation. What are two numbers that multiply to 12 but add to -8? Yep. -6 and -2. That means when the y value is 0, in other words, when the function is equal to 0, x must be +6 or +2. So the x-intercepts are 6, 0, and 2, 0. Super straightforward, as long as you know how to factor. Does this ring a bell to everyone? Sort of. You've done this for the catapult, you've done this for Desmos. It should ring a bell. Let's see it in action when we do this funky thing called the quadratic formula. Right? And my expectation is that my x value should still be a 6 or a 2. But we're going to use this formula. So here we go. Ready? Follow me. Write x equals, my b is a -8. So it's -8 plus minus -8 squared minus 4 times an a times a c. All of this is over 2 times a. Now, this formula isn't some magical formula we pulled out of nowhere. There is a logic behind this as well. But number one, you don't have that much time today. Number two, I'm not sure how many people will be curious for it or would even appreciate it. I have absolutely no problem showing you how to get there. So please let me know if that's the case. But yeah. Right now, let's learn how to use it. It should be just one. Okay. I think it should just be the stapled one. You already have that sheet. Yeah, just the stapled one. Okay, so we're going to work it out. -8, so -1 times -8 is a +8. -8 squared is a +64. And then work it out in your calculator. -4 times a 1 times a 12 is going to be -48. You can confirm my calculations if you like. Now let's keep going. It would be nice if we could simplify this a little bit. This is 8 plus minus 64 minus 48. This will give you 16. So in other words, this is going to be 8 plus minus a 4 divided by 2. Okay. So let's answer some more questions. What does that plus minus mean? It means it could be either or. By that, I mean, you're going to have to try both. So one person can try 8 plus 4 over 2. Another person can try 8 minus 4 then over 2. I'd like you to try this. Some people will plug in x plus 4 divided by 2 without any regard for bedmass, and so you might get a wrong answer. So everyone, I'd like you to try x plus 4 divided by 2 and see if you can get the right answer. I don't want you to make a careless calculator mistake. So take out your calculator once you're ready and tell me what answers you get. I will pause the video. Numbers. Give me one of them, Levina.
8 plus 4 divided by 2 equals 6.
Good. Good. And not a 10. Okay, do you know what I'm talking about? If you plug into the calculator just 8 plus 4 divided by 2, the calculator will follow bedmass to the T. And they will think you have to do this first. So they will do 8 plus 2. But of course, the numerators are in brackets. You have to do that before division. It's actually 12 divided by 2, which is 6. And then 8 minus 4 divided by 2? Yeah, 2. So x is equal to 6 or x is equal to 2. Does that make sense? Those are the x-intercepts when the y value is 0. So the question is, why the heck would you use a super convoluted, super complex formula when you can just factor? Because we've been practicing factoring all this time. It is when we cannot factor. So this is the point. I mean, I intentionally opened Desmos, so I think this should be recording. If you look at the Desmos of the equation, or sort of the equation, the function that we've been working on, here are my x-intercepts, 2, 0, 6, 0. But if you turn the page, and everyone turn the page with me, my next graph is what? Same equation, but take a look at the very last number. It's an 11. It's 11. Take a look. Are there two numbers that multiply to positive 11 but add to negative 8? Right? Positive 11 but negative 8? None. Right? So there are no integers that work. So right now, as far as we know, it's impossible to factor. So it's impossible to find the x-intercepts. So do we give up? Well, that's the thing, right? I'm going to go to Desmos now. Do the x-intercepts still exist? Yes. In fact, these are the x-intercepts. And wow, that's a little annoying. Are you going to factor x minus 1.764 and then x minus 6.236? No way. But here is what we can do. We can still use quadratic formula because we can plug into our calculators. So our a value is still a 1. Our b value is negative 8. Our c value is 11. If it's impossible to factor, let's see if this works and gives us a number. When y equals 0, x is going to be a negative 8 plus minus negative 8 squared minus 4, 11, all over 2 times 1. And so this time, I will pause the video. I'd like you to simplify this. Make sure you don't make any silly, careless calculator mistakes. Solve this out and tell me what the two numbers of x are, what the two x-intercepts are going to be. I'm going to give you, how about I give you 2 minutes this time? Let's see. So quickly to simplify, my expectation is that you've at least tried this. That's still 64. This is negative 44 over 2. So that's going to be 8 plus minus square root of 20 over 2. Which means my x values are either going to be 8 plus root 20, and you know what, just to save myself some time, I'm going to calculate root 20 first and round it as best I can. I'm going to leave, just like the Desmos, the interface, I'm going to give myself 3 decimal places, or was it 4 decimal places? How much did Desmos give me? 3 decimal places. I'm going to make like Desmos and give myself 3 decimal places. It's going to be 8 plus 4.472 over 2, or x is equal to 8 minus 4.472 divided by 2. Someone do that for me? 8 plus 4.472 divided by 2, and 8 minus 4.472 divided by 2. Or at least check to see if I'm doing anything wrong. 6 point something. It's a 6.236. Would someone confirm? Yeah, thank you. And then 8 minus 4.472 divided by 2. It's going to be 1.764. That number actually looks familiar from Desmos. Does that work? So my x-intercepts, therefore, when the y value is 0, my roots are going to be this or this. Yes? For now. Yeah. I arbitrarily chose it because Desmos was giving me that. But let's keep it consistent. I think it'll be a good idea to do so. And yeah, so can you imagine trying to factor and turning the factor into y is equal to x minus 6.236 and then x minus 1.764. That is beyond my expectations for you. Okay, we're not going to do that, but it doesn't mean the x-intercepts don't exist. So if we were doing this as a catapult, it took either 6.2 seconds or it took 1.7 seconds, right? That's all it is. Before we get into word problems and see how we can apply this, I'd like you to just practice using this formula. So here's my homework for you. You still have to study for your quiz anyway, so I'm going to keep it light. Okay? Your homework for today. Okay? Of course, tweak your study sheet for quiz. Let's write it up. That's number 1. Number 2, practice completing the square plus some word problems that ask for vertex or anything like that. And number 3, once you're feeling confident, from chapter 4.3, Quadratic Formula, try question 3 from the homework sheet. So if you look at the very back page, there's a bunch of word questions I gave you. Number 3, the very first number on the sheet, are just straightforward K questions asking you to try the quadratic formula. Find me the x-intercepts. So these are your homework pieces. And we've got about 10 minutes.